Hi guys, and welcome to this video on everything you'd ever want to know about angles, especially with degree measurement. We're going to go past radian measurement this time, but we're going to talk specifically about classifying angles, what some special angles are, and some terminology including complementary and supplementary angles. So we're going to go ahead and get started here. And let's just go ahead and start with the definition of an angle. We tend to refer to an angle as being formed by two rays with a common endpoint. You might recall from geometry that rays start at an endpoint and extend forever and ever in one direction. But we would have our angle here, okay, and you're going to notice that I'll draw in an arrow here. We say we would orient this angle. So you could think of this angle as kind of rising up from this horizontal here. But we have our two rays, and we might as well use some other terminology here that we want to get familiar with. So since I pointed out this arrow, let's go ahead and take a look at it. You'll notice that the side or the ray that my angle left from, we're going to call this the initial ray or initial side, and we're going to refer to the top side here then as being the terminal side. Terminal. You could think of terminate, which would mean to stop. Okay, and it's actually really important because we talk about positive and negative angles quite often, and the common endpoint that these share, of course, are referred to as vertices, or a singular would be vertex. Okay, so in basic, that's what an angle is. We tend to refer to, however, angles in standard position a lot of the time in trigonometry. So what the heck is standard position, you might say? We say standard position is any angle in which the initial side is the positive x-axis. Okay, so you could think of, we're always kind of leaving from over here on this positive x-axis, all right? So we would say an angle in standard position might look like this. We have this angle here, and we could say, okay, here's one angle. We could say another way to look at this is we've got an angle that might extend downward. How about this angle right here? We've got an angle here, and it comes back over to here, and we orient it this way. You'll notice that the key difference between these two angles, one of these angles, and we'll say this one here, spun upward from this horizontal, and we typically refer to this as an angle of elevation in application problems. And although I would refer to this one over here not as an angle of depression, we tend to refer to as angles of depression as being any angle that opens downward from what we call the horizontal, typically the positive x-axis. Okay, so we say depression, angles of depression. Moving right along, the primary difference between these two angles happens to be their orientation, or which way they were extending. So let's go ahead and point that out here. We would refer to this angle as, or classify it as being positive. We say any positive angle spins in a counterclockwise or retrograde motion. We refer to this as being a negative angle. Okay, so in terms of special angles that you'll want to know, of course, we refer to any angle less than 90 degrees as being acute, and an acute angle, and this would be an example of an obtuse angle, that is, it's greater than 90 degrees. Okay, so what would we call a 90-degree angle? Okay, we can sketch one of these up there. We refer to these, of course, as right angles, and we tend to put boxes there, and if you ever see a box there, it's no doubt it's a right angle, of course. And we say straight angles. A straight angle would be an angle that is, we say, here's our common endpoint here, 180 degrees. We say straight is 180, and then a full rotation is just a full rotation. So that would look like anything. It looks like this. Here's our two rays overlapping, and they would spin over on one another, 360 degrees. One full rotation. Okay. So I mentioned we were going to talk about complementary and supplementary angles in this video. Just real quick, complementary angles are two angles that sum to 90 degrees. So we'd say, like, for example, alpha plus theta are complementary if and only if they sum to 90. So complementary if and only if alpha plus theta equals 90 degrees. So we often want to find complementary angles, and likewise we would say that these things will go supplementary in blue. Supplementary if they sum to 180 degrees. So we're often concerned with these two things. So we'll take a minute to illustrate both. Let's say we had like a 40-degree angle. How about a 110-degree angle? And then how about a negative 30 degree angle, okay, because it's fun to go with negatives here. The first thing I think that is most important is that we're always sketching pictures in Trig, and that's just my opinion. But we'll sketch all of these angles in standard position, okay? So standard position, we know that the initial ray or initial arm or initial side of this angle, they're all on the x-axis, the positive x-axis, okay? So 40 degrees, well, you know, it's a little bit shy of 45, but it would open upward. We'd have a positive 40 degree angle here. 110 degrees, so that'd be like 90 plus another 20, and I'm exaggerating this a little bit here, but here's our positive 110 degree angle. And then negative 30 would be like this little slice down here. And we would be sure to indicate that it's opening downwards, but negative 30. And what I'd like to do with all of these is actually find their complementary and supplementary angles. So starting with 40, you know, a little bit of mental math gets you a long way on this one, but 40, we'd say, oh, well, I want the complement. So the complement would be anything I could add to this that would bring me up to a 90 degree angle. So we've already got 40 degrees. What could we do from this spot here to bring us up to the rest of this 90? So what I'm going to do is, for now I'm going to refer to this as the angle theta. This is the Greek letter theta. We often use theta to classify an angle. But we say, what could this be? I think powerfully here we could say algebraically, we say, okay, so 40 degrees from over here plus this unknown angle, what we want to be true is that they add up to be 90. And doing some simple algebra here, we could work backwards, subtract 40 from both sides, and we find out that theta is 50 degrees. And honestly, plugging that back in up here, we say theta being 50 degrees. If this was 50 degrees, of course, 40 plus 50 would be 90. An odd situation would be, what could you add to 110 to get 90? So I'm actually going to say, well, 110 degrees, we've already landed over here. It's like saying, how could we deviate from here to get back to this 90 degree mark here? And we'd actually have to go backwards, which means clockwise spin, which means negative. And honestly, there's that 20 degrees we had spoken about earlier. So we'd say the complement to this would be negative 20 degrees. Algebraically speaking, though, we'd say, what could we add? Like, what theta could we add to 110 to get 90? And subtracting 110 from both sides, we discover that, you know, you end up with negative 20 degrees. And then over here, I'd say complement. Okay, so we're already down at negative 30. What could we do to get us up to this 90 degree mark? Well, we're going to have to spin counterclockwise, which means positive. And we're going to spin this 30 here plus the other 90 that goes here. So complement would be like 120 degrees. Again, algebraically, we could say negative 30 plus what is 90 degrees. And we could back solve for theta. Finding theta is actually 120. Okay, so working from here, we say supplement. Why don't we switch colors real quick, and then we'll finish this little video up here. Light blue. Okay, so supplementary angles. We want supplementary angles to add up to 180 degrees. So going back over to this 40, we'd said we'd already been up to this point here. We want to spin it all the way over to 180 degree angle. So if we call this part here theta if we will, we say 40 plus theta has to be 180. So the same algebra we did previously, 40 plus theta equals a $1.80. We can subtract 40 from both sides, subtract 40. And you end up with theta is equal to 140 degrees, which back solving that here, you know, plugging that back in, makes total sense. Over here, we'd say, what could we add to this 110 to bring it up to 180? We always talk common sense here, but this would be 70 degrees. And just know that we want to bring that original negative 30 degree angle on the right here, kind of crooked there, back over to a 180. We'd have to add the 180 plus another 30 degrees here. But again, algebraically, we could say negative 30, you know, we like the algebra, plus what would have to be 180. We could add 30 to both sides and find that theta is 210. Okay, so hopefully this video helps out a little bit with angles.